Hey guys! Alright, today we're going to start Chapter 7, and Chapter 7 is called Probability and Simulation. So basically this whole section we're just going to start out with the basics of probability, and then we're going to move on to some more complicated probability stuff, including the multiplication counting principle and probability distributions, independent events, all that fun stuff. So Section 1 is pretty easy. It's just the basic principles of probability. So the first thing we have is some vocab. We've got experiments and outcomes. So an experiment is a situation that has several possible outcomes, and outcome are the results of experiments. So some examples of some experiments and outcomes. An experiment would be like tossing a coin, and the outcomes you get are either heads or tails. Or an experiment might be rolling a dice, and the outcomes that you get are 1, 2, 3, 4, 5, or 6. Or another possible thing would be like if you're tossing a coin twice, then you could get heads and then heads, or heads and tails heads, or tails and tails. Okay, so those are all examples of experiments and outcomes. We've also got sample space, which is the set of possible outcomes of an experiment. Okay, so over here on the notes when I listed out the actual outcomes, those are considered your sample spaces. And an event is any subset of the sample space of an experiment. So basically, an event would be like if I asked you to roll a die and get an even number. Okay, an even number is a subset of the possible outcomes that you could get from rolling a die. So that subset would be either getting a 2, a 4, or a 6. All right, so we've got some examples here. HH, that's heads, heads. That's an event of the sample space, heads, heads, tails, 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 heads, heads, tails, for tossing a coin twice. 2 is an event of the sample space, 1, 2, 3, 4, 5, 6, for rolling a die. So the first question says, list the outcomes of the event doubles, flipping a coin twice and getting the same side on both. So a double, that just means that you're actually doing the same thing twice in a row. So I know that if I were to flip a coin, I could get either heads, 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 tails, tails, heads, or tails, tails. So my event doubles would be getting heads, heads, or getting tails, tails. So the way that I would list out that sample space is I would have my bracket here, and I would write heads, heads, comma, tails, tails. Okay, and I would close that bracket too. So whenever you have stuff in brackets, that's considered a set. Okay, so we use set notation when we're talking about sample space. All right, next up we've got probability of an event. P of E is a number from 0 to 1 that measures the likelihood an event will occur. They can be written as decimals, fractions, and percentages. So our probability of an event is going to be the number of outcomes in the event over the number of total possible outcomes. Okay, or another way of saying that would be the number of outcomes in the sample space. All right, so we've got probability equals the number of outcomes in the event over the total possible outcomes. Now we've also got this idea of fairness. So something's fair if everything is equally likely to occur. So if a sample space has n outcomes, all of which are equally likely, then each outcome has the probability of 1 over n, and the outcomes are said to occur at random. So this idea of fairness is really important in probability because we like to talk about whether games are fair or not, and if a game does not have an equally likely outcome for you to win, then you probably don't want to play it. At the end of this chapter, we're going to do a project where we create casino games, and we're going to gamble on each other's tables. And so it'll be really important that you can think about, is this game going to be fair? Do I even want to put my money on this table? Okay, so that idea of fairness is really important. All right, some of the basic properties of probability. If S is the sample space associated with an experiment, and the probability of E is the probability of an event E, then we can say that the probability is between 0 and 1. Okay, so essentially 0, that's like saying that the event is impossible. Okay, it could never happen. It's a 0% likelihood that that thing would happen. Okay, that's what it means to have a probability of 0. A probability of 1 means that it is 100% likely to happen, meaning that it will always happen no matter what. Okay, so 0 and 1, those are our limits, going from 0, which is never happen, to 100, which is always happen. All right, and also, if your event is this empty set, okay, meaning that it's just 2 brackets with nothing in them, that is also something that is impossible to happen. We can't get that. Okay, we've also got relative frequency. So similar to probability, a number from 0 to 1 that measures how often an event occurs during an experiment is called your relative frequency. So probability measures the likelihood that an event will happen, just theoretically, and relative frequency measures the likelihood that an event will happen based on experimental data. So essentially, if you have a relative frequency of 0, that means that it hasn't happened yet, but it doesn't necessarily mean that it can't happen. Okay, so relative frequency is based on experimental data, whereas probability is based on theoretical data. So our second question says, you toss a coin 10 times and get 0 tails. Does this mean the probability is 0 or the relative frequency is 0? Well, the answer is that the relative frequency is 0 because that's based on our experimental data. That does not necessarily mean that it could never happen, it just means that it hasn't happened yet in our experiment. All right, the next question says, assuming the birth of boys and girls are equally likely, find the probability a family of 3 children has exactly 2 girls. Okay, so when you approach a problem like this with probability, I would say that the best place to start is by listing out the sample space. So if I have boys and girls and they're equally likely, I'm going to assume that's 50-50. Okay, find the probability a family of 3 children has exactly 2 girls. So if I've got 3 children, I'm just going to say G stands for girls and B stands for boys. So in my sample space, I could have 3 boys, so that would be B, B, B. Okay. I could have 2 boys and 1 girl. And I could have the 2 boys first, I could have the girl first, or I could have the girl in the middle. Okay. Or I could have 2 girls and 1 boy. So I could have 2 girls first, or I could have the boy first, or I could have the boy in the middle, or I could have 3 girls. So this is my sample space for a family with 3 children. Okay, and basically the order does matter on whether you have a boy or a girl first. So think about your family. Maybe you have an older brother or something. It would change if he was your younger brother. That would be a little bit different. Okay, so the order for these families does matter. So I've got 8 possible outcomes here. And I want to figure out the likelihood of getting 2 girls. So I'm going to just circle all of my possible situations where I have 2 girls. Okay? So remember that the probability of an event is the number of outcomes in the event over the number of outcomes in the sample space. So I have 3 outcomes in my event over a total of 8 possible outcomes. That means that the probability of me having 2 girls in my family of 3 children is going to be 3 out of 8. All right, that's everything.